Good day, everyone. My name is Daphne M. Castañeda. I'm studying at Polytechnic University of the Philippines. I'm from Institute of Technology. I'm a third-year student currently taking Diploma in Computer Engineering Technology. First, what is a cloud infrastructure? Cloud infrastructure is a word that refers to the hardware, abstracted resources, storage, and network resources that are required for cloud computing. Consider cloud infrastructure to be the technologies required to create a cloud. Cloud infrastructure is required to host services and applications in the cloud. How does it work? Virtualization is one example of an abstraction technique or process that separates resources from physical hardware and pulls them into clouds. Automation software and management tools allocate these resources and create new environments so users may get what they need and when they need it. For the components of AWS Cloud Infrastructure or Amazon Web Services, there are services for computing, storage, database, and security. Computing services. AWS Compute is a collection of physical computers that provide memory, processor, and storage infrastructure to an operating system. When it comes to cloud computing, the server's operating system software acts as a hypervisor, giving layer of abstraction over the hardware. The Elastic Compute Cloud, or EC2. In the AWS Cloud, Amazon Elastic Compute Cloud, or Amazon EC2, provides scalable computing power. Using Amazon EC2 reduces the requirement for upfront hardware investment, allowing you to create and deploy apps more quickly. Amazon EC2 allows you to create as many or as few virtual servers as you need, as well as establish security and networking and manage storage. You can scale up or down on Amazon EC2 to manage variations in demand or popularity spikes, decreasing the need to anticipate traffic. Creating an Amazon Machine Image or AMI, which comprises an operating system, programs, and customizations, is the first step in the EC2 setup process. The AMI is uploaded to Amazon Simple Storage Service or the S3 and registered with the EC2, allowing customers to start virtual machines whenever they need them. Amazon provides many EC2 instance types for various needs and budgets, including hourly, reserved, and spot prices. The LAMBDA. AWS Lambda is Amazon's event-driven, serverless computing technology, which is part of Amazon Web Services. It's a computing system that runs code in response to events and maintains the computing resources needed by that code autonomously. The Autoscaling Group. For the purposes of automated scaling and administration, an autoscaling group is a collection of Amazon EC2 instances viewed as a logical grouping. You may utilize Amazon EC2 autoscaling features like health check replacements and scaling policies when you create an autoscaling group. The Amazon EC2 autoscaling services fundamental operation is to keep track of the number of instances in an autoscaling group and to automatically scale them. For the storage services, cloud storage is a cloud computing approach in which data is stored on the internet and managed and operated by a cloud computing provider. It's on demand. With just-in-time capacity and pricing, it saves you money by not having to acquire and manage your own data storage infrastructure. With anytime, anywhere data access, you get agility, global scale, and durability. The Amazon S3. Amazon S3 is a simple storage service with industry-leading scalability, data availability, safety, and efficiency. Customers of all sizes and sectors can store and safeguard nearly any amount of data for use cases including data lakes, cloud-native apps, and mobile apps. You can minimize expenses, organize data, and established fine-tuned access restrictions to suit particular business, organizational, and compliance requirements with cost-effective storage classes and easy-to-use administration tools. The Amazon CloudFront. Amazon CloudFront is a developer-friendly content delivery network service that securely distributes data, videos, apps, and APIs to customers across the world with low latency and high transfer rates. The database services. By implementing backup and recovery methods, providing a secure database environment, and monitoring database performance, database services guarantees that customer databases are safeguarded and managed. Relational Database Service or RDS. Amazon RDS makes it simple to set up, run, and scale a relational database in the cloud. It offers scalable capability at a low cost while automating time-consuming administrative activities, including hardware provisioning, database setup, patching, and backups. It allows you to concentrate on your applications, ensuring that they have the performance, ability, security, and compatibility they require. The security services. AWS Data Security Services monitor and safeguard your accounts and workloads by encrypting and managing keys, as well as detecting threats. AWS detects risks in your cloud environment by continually monitoring network activity and account behavior. AWS Identity and Access Management. AWS Identity and Access Management, or IAM, allows for fine-grained access management throughout the whole AWS infrastructure. You can control who has access to which services and resources and under what conditions using IAM. You control rights to your workforce and systems with IAM policies to guarantee least privilege permissions. IAM is a free service provided by Amazon Web Services. The pricing model. AWS provides over 200 cloud services with a pay-as-you-go pricing model. You just pay for the services you use on AWS and you don't have to sign long-term contracts or deal with complicated licensing. Pricing for AWS is similar to that of utilities like water and electricity. Despite the fact that price structures differ by service, it's important reviewing essential ideas and best practices that are universally relevant. The pricing models on AWS, the on-demand, pay for compute capacity by the hour with no long-term commitments. Reserved, make a low one-time payment and receive a significant discount on the hourly change. And lastly, the spot. Bid for unused capacity charged at a spot price, which fluctuates based on supply and demand. Cloud advantages and disadvantages. Cloud computing appears to be the word of the year, and more companies are adopting it on a daily basis. While using cloud computing to optimize IT operations can make day-to-day computing much faster, and it's not something to get into immediately. Advantages. Accessibility. You may access your data from anywhere at any time. By guaranteeing that your application is always available, an internet cloud architecture boosts company productivity and efficiency. This makes it simple for users in different places to collaborate and share information. No hardware. A physical storage center is no longer required because everything will be housed in the cloud. However, in the case of a tragedy that causes your company's output to stagnate, a backup can be worth considering. Recovery in an efficient way. Cloud computing allows users to get programs and data more quickly and accurately. It is, it is the most efficient recovery approach since it requires minimum downtime. Disadvantages. Possible limited features. It's possible that you won't get all of the features. All cloud services are not created equal. Some cloud providers provide restricted versions that simply activate the most popular features, so you may not get all of the functionality or customizations you desire. Make sure you understand everything your cloud service provider has to offer before signing up. Access to the Internet. In cloud computing, reliable Internet access is essential. You can't use the cloud if you don't have to access the Internet. Furthermore, there is no alternative means to collect data from the cloud. Downtime. When dealing with cloud computing, it's also important to factor in downtime. This is due to the fact that your cloud provider may have power outages, poor internet access, and service maintenance, among other things. Regardless of the benefits and drawbacks of cloud computing, we cannot dispute that it is the fastest expanding segment of network-based computing. It benefits consumers of all sizes, including basic users, developers, companies, and all sorts of businesses. As a result, this technology will be around for a long time. What is agile development progress and how is it used in modern technology development? Agile software development is a collection of rapid application development approaches in which requirements and solutions emerge from cooperation among self-organizing cross-functional groups. The agile development process gives structure to what is otherwise a fluid and flexible technique of getting a functional product out the door. It has stages that can assist the structure of your work. By splitting your builds into smaller pieces, you can offer a far more value product to your consumers in a much less amount of time. The agile development process, which consists of planning, analyzing, design, implementation, testing, and maintenance. It is important to be used for project management and software creation to assist teams in delivering value to consumers faster and with fewer difficulties. An agile team provides work in tiny, digestible chunks rather than relying on a sudden lunch. The agile project management and software development progress is built to be adaptable to change. Agile project management is a method of planning and leading project activities that is iterative. An agile project is finished in tiny portions, just as agile software development. Iterations are the name for these parts. An iteration is a single development cycle in agile software development, for example. Agile project management is meant to be flexible enough to handle projects with possibly shifting, changing, and evolving needs, as well as agile enough to provide functional components of the total final solutions to the end customer quickly and as needed. It goes beyond the rigor of the waterfall method by accepting the scope changes that might occur with even the most focused requirements projects. Planning. Agile team members break down features into tasks, which are then assigned to team members. Look at the time estimates and attempt to break down any work that will take more than a day into smaller activities as a recommended practice. This aids in the reduction of uncertainty and the fulfillment of tasks. It also helps in estimating because estimating the time necessary to perform a smaller activity is considerably easier. Analyzing. Part of that work is imagining the requirements and architecture in advance so you can answer crucial questions regarding the project scope, cost, timeline, and technological approach. During iterations, details about the business domain are determined just in time via, via initial iteration modeling, at the start of each iteration or modeling storming during the iteration. For Agilists, analysis is so crucial that it must be done on a daily basis. Design. The Agile design technique requires designers to collaborate with other team members, for example, developers, marketers, etc., on a continuous basis. This aids in the development of a sense of ownership for the project as well as the development of trust among team members. Design hasn't been thought of as an iterative process for a long time. Designers are frequently pressured to begin working on high-fidelity prototypes right away. This frequently resulted in ill-conceived goods that failed to appropriately answer consumers' demands. On the other side, the agile design process is an iterative technique. The following is a simple flowchart of the procedure: understand, research, sketch, design, prototype, test, and refine. This method enables designers to do more than simply create a product, since they can improve the design of a product with each iteration and tackle key challenges. As a consequence, the user experience and customer satisfaction will improve. Implementation. The practice of executing a flexible project plan based on producing small sections of a project at a time is known as agile implementation. Sprints are a set of preliminary and loose release dates for those parts of the plan that allow for ongoing adjustments depending on current business demands. Testing. Agile testing is software testing that adheres to Agile's development's best practices. Agile development, for example, uses a step-by-step approach to design. Agile testing, too, takes a step-by-step approach to testing. Features are checked as they are developed in this style of software testing. Maintenance. Agile development teams use incremental design and development to help them find the best solution via trial and error. Maintenance teams operate in this manner for a different reason: to control technical risks by breaking down large modifications and making little bets rather than large ones. The Steps for the Agile Progress provides a lightweight framework that aids development teams in coping with a continuously changing functional and technological landscape while also emphasizing continuous delivery. The organization may lower the overall risk involved with software development by using this technique. DevOps in modern technology management. DevOps is a collection of methods, technologies, and a mindset that automates and connects application development and IT teams' activities. Team leadership, cross-team collaboration, and technological automation are all emphasized. Its purpose is to communicate, connect, automate, and collab directly amongst all parties involved in the planning, development, testing, deployment, delivery, and maintenance of a service, which is why DevOps is relevant in the modern technology. DevOps team speeds up the creation of software applications, and they can deploy and upgrade IT goods at the speed of the competitive market thanks to a more responsive approach to IT infrastructure management. Continuous development. We aren't flawless, and technology evolves at a rapid pace. Improving yourself, your team, your procedures, and your company are all part of altering your culture. Because failure is unavoidable, it's, it's critical to prepare your team to absorb it, recover fast, and then learn from it. Failure in DevOps isn't always a bad thing. It may be a valuable learning experience. Continuous delivery lowers the risk of a release and makes systems more stable and robust. This is accomplished by automating the build, deploy, test, and release processes, which lowers the cost of executing these tasks and allows us to do it on demand rather than at a set frequency. As a result, Developers, testers, and operators can work together more effectively. High-performing teams expect things to go wrong now and then, so they design for quick detection and recovery. DevOps will fail if a high number of test cases must be manually executed. We all make errors, no matter how hard we try, since we are just humans. Testing automation comprises acceptance tests, or also known as behavior-driven development, integration tests, and regression tests, in addition to executing unit tests as a part of a continuous integration system. The four benefits of automated testing. 1. Reduces specification and comprehension mistakes. 2. Reduces risk by allowing users to rerun tests on demand rather than arranging resources to do so. 3. Allows individuals to solve issues while machines execute monotonous activities. It allows your testers to concentrate on the difficult issues. 4. During automated testing, test data and fixtures may be maintained and reused.